Hello, we are the Windbreakers, and our project this semester was to design and build a portable, efficient micro-wind turbine. Micro-wind turbines are a relatively unexplored concept that could prove to be very important in the future of green energy. Wind turbines convert kinetic energy from the wind into mechanical energy in the wind turbine shaft and then into electrical energy through the use of a generator. Due to their small size, micro-wind turbines are a cost-effective way of harnessing the renewable energy of the wind. Our initial prototype had 4 twisted vanes that allowed material to be helically wrapped around a vertical shaft. However, after testing, we realized that our micro-wind turbine had a small moment of inertia. This was due to the fact that we had the shaft turning inside the bearings. There was also a large amount of losses in the sail material that was being used to catch the wind. Due to these problems, our micro-wind turbine failed to rotate on its axis. In order to resolve this, we decided to change our design. Our beta design was based on a gyro mill. This design consists of 3 fins held between 2 vanes spinning around a fixed shaft. We needed to ensure our micro-wind turbine would be stable, so we manufactured the shaft to fit tightly into a box. This box provided a strong base for our micro-wind turbine. The shaft was made out of a crutch and the box was made out of plywood. The 2 vanes were attached to the shaft using a bearing and sleeve for each of them. The bearings were sourced from an old car, the vanes were made from plywood, and the sleeves were cut from an aluminium cylinder. Blocks of wood were added to the outer edges of the vanes, which increased the inertia of our micro-wind turbine and simultaneously provided a place to attach the fins. The use of screws and the crutch in our device allowed us to create a collapsible micro-wind turbine which improves its portability.
Here we can see the turbine in operation. A piece of wood attached to a bearing allows us to connect our spinning turbine to a motor using a nylon rubber belt. The belt turns the motor, producing a current in the wires. The motor is producing a current of 7.23 amperes, which leads to an output of approximately 351 millivolts.